Hi there everyone, welcome back to another Further Maths video. Today we'll be covering question 12 from the OCR 2020 Pure Core 1 paper. As you can see, this is an integration question, but it incorporates a few other ideas so that it makes it slightly more complicated, which is why it's worth 6 marks. And it's also the last question on the paper. So we're going to get straight into this question. Show that this integral given is equal to ln a plus root b plus pi over c, where a, b, c are integers to be determined. So the first thing to think about is that we've been given the exact form that they need, so we need to give an exact answer. And in this answer, they have this ln, and when we have ln, we know that we should be integrating 1 over something something x, right? So that's one clue, because that's when we integrate that, we get ln something something something. And the second thing is, when we have a pi, we know that we should be doing something probably with trigonometry. So we're going to be doing something with sine, cos, and tan. So I'm just going to rub this out real quick, and we'll actually start solving this question. Those are the first few things to be looking at. So the first thing to notice is that in this 1 minus x to the power of 4, so that's the integral 4 over 1 minus x to the 4 that we're trying to integrate, there is a trick which we can use to split this up, and that's called difference of two squares. This should be a common technique from A level as well, but it's a bit harder to identify when you have x to the power of 4, and that's because 1 minus x to the power of 4 is also equal to 1 minus x squared. So, and we know that 1 squared is also equal to 1, so we can actually split this up further, and what we can do is we can say 1 over root 3 of 0, between the integral between 1 over root 3 and 0, or 4 over 1 minus x squared, 1 plus x squared, let me extend that line, dx, and that's kind of the integral we're now going to be solving. But if you're kind of keeping your eye out, you can see that we can split this integral even further to be able to solve it, because we're not really able to solve this integral yet. We don't really know how to do partial fractions on this yet. So we can split this up further and do 1 over root 3 and 0, or 4 over, and what we see is this term, we can still do difference of two squares again on this term, because you know 1 is just equal to 1 squared, so these are both squares. What we can do is we can say this is equal to 1 minus x, 1 plus x, and 1 plus x squared dx. So now we've been given, we've found out kind of this new form for this integral, and we're going to have to split it up via partial fractions to be able to solve it. And that's kind of the new topic that we're kind of introducing. So this is a topic that you also have to use at A level, but there is kind of a new thing in terms of this term here. This 1 plus x squared term is something that we don't know how to kind of do, and we don't know how to do the partial fractions for that term in A level. So, something's happened here. There we go. So that's important to be able to solve now. So what we're going to do is we're going to try split this up via partial fractions. Now the key thing to know is that usually if you're doing 4 over 1 minus x and 1 plus x, and we're trying to split this up via partial fractions, what we'll do is we'll do a over 1 minus x plus b over 1 plus x, and that's it. But now that we've added this final term, 1 plus x squared, we actually have to add a different term. It's not just c over 1 plus x squared, that's incorrect. We actually have to do cx plus d. So the way to think about it is whatever the highest term is, so this is x squared, so the highest term is at the power 2, you have to do 1 less, so I have to do power 1 of x. In the rest, the highest power is 1, so on the numerator I do the highest power is x to the 0, which is 1, which is why it's not there. So now that we've got this in this form, we're going to split up via partial fractions, and what we're going to do is we're going to write 4 is equal to a, and we've already been given this 1 minus x term in the denominator, so we need the other two terms in the numerator. So we have 1 plus x, 1 plus x squared. For the b, we've been given the 1 plus x term, so we have the other two terms, so 1 minus x and 1 plus x squared. Now in the cx plus d term, I'm going to write that in brackets just to make it clearer, make sure I multiply everything and expand it all correctly. We've been given the 1 plus x term, so we need the other two terms, which is just 1 minus x squared. Because we expanded it out before, so we're going to introduce it back now. So then, once we've done this, what I'm going to do, there's two ways to kind of find the coefficients a, b, c, and d now. One is equating the coefficients, but what I'm going to do right now is just sub in random values, because one is quite a nice term to use, so I'm just going to sub in random values of x to kind of equate these coefficients. So what I'm going to do is I'm going to try to get rid of this bracket so that I can get rid of the a term. And the value I'm going to use is x equals -1. And then what that'll give us is x is equal to 0a plus 1 minus -1 is 2. 1 plus -1 squared is also 2. So 4 equals 4b. That means b is equal to 1. Then we have x is equal to 1 is the other term we can use, and that will get rid of this term here. So this will make b 0 and also cx plus d 0 as well. So then we have 4 is equal to 4a, because 1 plus 1 is 2 and 1 plus 1 squared is also 2. And that will give us a is equal to 1. So very nice number so far. And then we need to there's no way to cancel a and b now, so we'd have to use the fact that a and b are 1. And we'd have to what I'd do is I'd try to get rid of this c term here, so that I have just d, because I already know a and b. So I'll put x is equal to 0 for now. And with x is equal to 0, I'm going to do 4 is equal to 1 plus 1 . 1 plus 1 plus 0x plus d, and 1 minus 0 is just 1, so that's also just 1 here. And what we can do is we basically see that this is just d on one side and the 1 plus 1, so we know d is equal to 2. And the final final x value I'm going to use is just x equals 2, just a random value. And what we get is 4 is equal to a 3. Oh, sorry, not a is equal to 1, so we don't even need to include this. We can just do 3, then 5 plus b, so b is 1, so it'll be 1 minus 2 is -1, and this is also 5. And then we have cx, so that will be 2c plus 2, because d is equal to 2. 1 minus 2 squared is -3. So we have 4 is equal to 15 minus 5 minus 6c minus 6. And what this gives us is that, this gives a very nice answer of c is equal to 0, if you solve that out. So that gives us a very nice answer. So now if we rewrite this kind of integral, we get 1 over root 3, 0, can be written as 1 over 1 plus x plus 1 over 1 minus x plus 2 over 1 plus x squared dx. Now, we kind of move on to the next section, which is solving the integral. First, we kind of rearranged it into a form where we can integrate. Now we actually have to do the integral and find an exact value for it. So straight away, we should be able to do these pretty simply just from A-level maths. So this would give us the ln, kind of the ln part of it, because 1 over 1 plus x is very easy. It's just ln 1 plus x, and then 1 over 1 minus x would give us negative ln 1 minus x, so I'm going to write those down. So this equals to ln 1 plus x negative ln 1 minus x. If you're not able to kind of do these really quickly, then you should look over your A-level integrals. But this term is different, and if you look at your formula sheet, you should be able to see something that applies, and it's that this is the inverse trig kind of integration and differentiation, so inverse trig calc. So 1 over 1 plus x squared, the integral of that, we know that it goes to tan minus 1 of x, and we know that from the formula sheet. Oh, this should be plus c. So what we're going to use is we're going to actually use that and do plus 2 tan minus 1 x between 1 over root 3 and 0. Now what we're going to do, I'm going to delete this. We're going to just plug in the values, so we get ln 1 plus 1 over root 3, negative ln 1 minus 1 over root 3, plus 2 tan minus 1, 1 over root 3, and then take away. So ln1 is just 0, so take away 0. Then negative, so negative make positive, but ln1 is again 0, so that's 0. And then we take away 2 tan minus 1 of 0, which is also actually 0, so this is also 0, so we can also get rid of this term as well. Now we're left with these three terms. Now, tan minus 1, 1 over root 3, you can actually put that in your calculator and it would give you pi over 6. So straight away, I know that this term is going to be 2 pi over 6. Now these terms, these two terms here, what I'm going to do is use my log laws, and I know that if I have a negative, this means divide. So this can be rearranged as 1 plus 1 over root 3 all over 1 minus 1 over root 3. And I'm going to put a plus sign there. And now what I'm going to do is try rationalize, or actually I'm going to have a common denominator. I'm going to try get rid of these two fractions here and put everything over root 3. So this gives me ln root 3 plus 1, because if I put this, this is also root 3. 1 is also equal to root 3 over 3. So this is root 3 plus 1 all over root 3 all over root 3 minus 1 all over root 3, and I'm going to extend these brackets down, plus pi over 3. And these root 3's will cancel, so we get ln, let me move this down, ln root 3 plus 1 over ln root 3 minus 1 plus pi over 3. And what I can do is I'm just going to write on the side here, root 3 plus 1 over root 3 minus 1. From either GCSE or A levels, you should know how to kind of rationalize the denominator for this. So we do root 3 plus 1 over root 3 plus 1. We times both sides by the same thing. And that gives us 3 plus 1 plus 2 root 3 on the top. And it gives us 3 negative 1 on the bottom. So this is equal to 4 plus 2 root 3 all over 2, which is equal to 2 plus root 3. So our final answer is that this integral is equal to ln 2 plus root 3 plus pi over 3. So that is the end of that question. We've got the final answer. Now the main difficulty kind of with this question is less about the kind of difficulty of integration. It's just about combining the fact of the partial fractions and using the further math technique for partial fractions, which is about this cx plus d term here. And then also being able to do inverse trig calc, which is something new to further maths as well, and combining all those kind of topics into one question. So it's quite a nice question, but I hope that obviously you don't get stuck on this in the future, and I hope you kind of understand the kind of tips and tricks on how to spot when to use each type of technique. And I hope you enjoy the video, and see you in the next one.